Good morning, children. Welcome to our chemistry online class. We have completed the chapter hydrogen. Today onwards, we are starting the new chapter, that is S block elements. S block elements consist of two groups. What are they? Group 1 and group 2. Today, we are studying about group 1 elements. Group 1 elements in the periodic table are known as alkali metals. What are those? Lithium, sodium, potassium, rubidium, cesium and francium. We'll see the properties of this element. Why they are known as alkali metals? When they react with water, it will produce bases, that is alkali. For example, we know the very famous bases: sodium hydroxide, potassium hydroxide, lithium hydroxide. These all are the hydroxides of alkali metals. When they react with water, which produce alkalis or bases. That's why they are known as alkali metals. And what is the electronic configuration of them? Any idea how to write the electronic configuration? If you see this image, you can see they have the same type of electronic configuration. The last electron enters to the same valence shell, that is S shell. If you check with alkali metals and alkaline earth metals, the last electron enters to the S subshell. That's why they are known as S block elements. So, the last shell enters to the S subshell, that is S1. So, this is the electronic configuration of this element. We will see the other properties of alkali metals. Okay.
So, the elements of group 1 of the modern periodic table constitute the alkali metals. We'll see what are they. That is lithium, sodium, potassium, rubidium, cesium, francium. These are alkali metals. The first group elements in the periodic table. The occurrence. They are highly reactive metals and thus they are not occurring in the free state. The unreactive metals will occur in the free state. But if we take the alkali metals, we know they are highly reactive, hence this do not occur in the free state. This mostly occur in the form of halides, borates, silicates, nitrates and oxides. Some of the alkali metals occur abundantly in nature. For example, sodium is 7th and potassium is 8th abundant element by weight in the earth crust. So, sodium and potassium can see abundantly in the earth crust. We'll see some of the properties of alkali metals. If we take alkali metals, we know the electronic configuration of alkali metals is NS1. The outer electronic configuration is NS1. For example, if we take lithium, it is 1s1. If we take sodium, it is 2s1. Potassium, 3s1. Similarly, it will go so. So, if we check with the reactivity, we know in the valence shell, that is in the s electron, it contains only one electron. So, it is very loosely bound electron because it is the valence shell electron. So, it can donate one electron so easily. So, hence, they are electropositive metals. We know if an atom donate one electron, it will become positive in nature. So, they readily lose electron to form monovalent ions because it's contain one electron in the valence shell. Hence, it is easily donate one electron and became the monovalent ion. Because of this, if we donate one electron, one monovalent electron, it became the positive charge, that is cation. Hence, it is not found in the free state in the nature. If we check the reactivity of the first group elements, you can see here lithium, sodium, potassium, rubidium, cesium. So in here lithium is least reactive and cesium is most reactive in the nature, because if we compare these elements moving down the group from that is from lithium to cesium, if you check, you can see the atomic size, that is atomic radius, increases down the group. So the nuclear attraction on the valence shell will decreases. Hence the cesium can easily remove one electron compared to lithium. So cesium is highly reactive compared to lithium. So the next one, so the electronic configuration is, outer electronic configuration is ns1. For lithium it is last shell configuration 1s1, for sodium 2s1, like it will go so. So the last shell valence shell contain one electron. And next one is atomic and ionic radii. We know the alkali metals atoms have the largest size in a particular period of the periodic table. We know that we have studied already in the periodic table. While moving down the group, the atomic size increases. Moving left to right, the atomic size decreases. So we know alkali metals are the first group elements. Hence, they have larger size compared to all other elements in a period. With increase in atomic number, the atomic and ionic radii of alkali metals increases. That all things we know. So hence, from moving down, that is lithium to cesium, the atomic size increases. And ionization enthalpy and hydration enthalpy. We know what is ionization enthalpy and hydration enthalpy. Ionization enthalpy is the amount of energy required to remove the most loosely bound electron from the valence shell. So, if you check with the ionization enthalpy of the alkali metals, it is considerably low while moving down the group from lithium to cesium. That we know, because while moving down the group, what will happen? While moving down the group, the atomic size increases. Hence, the effective nuclear charge on the valence shell decreases. So, an electron can easily remove from the valence shell compared to lithium. Cesium having the high energy because it is low energy because it is having large atomic size. So, the atomic size or hydration enthalpy order is like this. First, lithium having high energy compared to cesium. We'll see the physical properties. Here you can see the comparative study of atomic radius and ionic radius. And while moving down the group, you can see atomic size increases. Similar to that, ionic radius also increases. Now we'll see the chemical properties of alkali metals. So, we'll see the reactivity towards air, reactivity towards water, reactivity towards dihydrogen, reactivity towards halogens, reducing nature and solution in liquid ammonia. We'll see these much chemical properties. So, we'll see first reactivity towards air. How the alkali metals reacted in the air. If we check the alkali metals, they will tarnish in dry air due to the formation of their oxides. So, when alkali metals reacted in air, it will form its oxide. If it is react with moisture, it will form hydroxide. For example, lithium plus oxygen give lithium oxide. Sodium plus oxygen gives sodium peroxide. So, the first member only give oxide, the second member will give peroxide, So the general trend is alkali metals plus oxygen, which gives superoxide, that is having formula MO2. Instead of M, we can put any other alkali metals. Only lithium and sodium will give oxides and peroxides. All other elements will give superoxides. And reactivity towards water. That we know why they are known as alkali metals. When these alkali metals reacted with water, which give bases or alkali, that's why they are known as alkali metals. So they react with water, which produce bases or hydroxide. For example, the alkali metals, instead of M, we can put any alkali metal which react with water to produce bases. Then reactivity towards dihydrogen. The alkali metals react with dihydrogen at about 673 Kelvin. For lithium, it is 173 Kelvin to form hydrides. For example, instead of M, we can put lithium, sodium, potassium, etc., which give lithium hydride, sodium hydride, potassium hydride, etc. They are ionic solids having high melting points. Then reactivity towards halogens. That we know very well, very important compounds are formed between alkali metal, between the reaction between alkali metals and halogens. The alkali metals readily react vigorously with the halogen to form ionic halides. For example, NaCl. Sodium is an alkali metal which reacts with the halogen chloride, which form NaCl. But lithium is very small in size and has high tendency to distort electron cloud. Hence, it form not ionic compounds, it form mostly covalent in nature. The next one is reducing nature. We know the alkali metals are highly reducing, strong reducing agents. Sodium is the least powerful, lithium is the most powerful. Which are the uses of the alkali metals? Lithium is used in making alloys. Lithium carbonate is used in making special kind of glasses. Lithium aluminum hydride used as a good reducing agent in many reactions. Along with sodium is used in softening of hard water, laundry and cleaning. It is also used in paints and dyes. Sodium is also used in paper and textile industries and as a reagent in laboratories. You can see general characteristics of the compounds of the alkali metals.